The view, or view collection as Java calls it, doesn't store elements but depends on a backing collection that stores the data elements. You saw this with the headset, tail set, and subset methods on sets. You're also very familiar now with a list backed by an array, a view we get back when we use the arrays dot as list method to get an array in the form of a list. You'll remember when we make changes to that list, the changes are reflected in the underlying array and vice versa. The functionality available to us on the list is limited to features supported by the backing storage, so for a list backed by an array, we can't add or remove elements as an example. You might be familiar with database views which hide the details of the underlying data structures to make it easier for clients to use the data. These view collections serve a similar purpose. They let us manipulate the collections without really having to know the exact details about the storage of the data. In other words, we don't have to keep learning new methods to manipulate data. As long as we can get a collection view of the data, we can use many of the collection methods to simplify our work. On this slide, I'm showing you a high-level overview of the structure of the HashMap class. First, it's important to know that there's a static nested interface on the map interface and that its name is entry. Concrete classes implement both the map interface and the map.entry interface. The HashMap implements map and has a static nested class node that implements the map.entry interface. The HashMap maintains an array of these nodes in a field called table, whose size is managed by Java and whose indices are determined by hashing functions. For this reason, a HashMap is not ordered. I want to focus now on the three view collections we can get from the map. These are the key set, the entry set, and values. We know a map has keys, and these can't contain duplicates. These keys can be retrieved as a set view by calling the key set method on any map object. Each key value pair is stored as an instance of an entry, and the combination of the key and value will be unique, because the key is unique. A set view of these entries, or nodes in the case of the HashMap, can be retrieved from the method entry set. Finally, values are stored and referenced by the key, and values can have duplicates, meaning multiple keys could reference a single value. You can get a collection view of these from the values method on a map instance. Let's look at these views in some code. Getting back to the Sets and Maps project, I want to create a new class called MapViewsMain. I'm going to create a new map with string as the key type and contact as the value type. I'll set that to a new HashMap. I'll follow that with a call to get data on contact data, passing it the phone type and chainer for each to that. In the Lambda expression, I'll make a call to the put method on contacts, pass the contact name as the key, and the contact object as the value. I'll copy that statement, pasting it, changing the type from phone to email. Next, I want to get a view of my keys, and I can do that with the key set method on a map. I'll create a local variable with a type of set and type argument string. I'll call it keysView and assign that to contacts.keyset. After that, I'll just print that variable out. Since the method keyset returns a set and not a map, I need only one type argument in the declaration, and that's the type of the key, a string in this case. If I run this now, you can see the keys, my contact names printed in no particular order. If I had used a constructor, for example, perhaps a tree set, I would not actually get a view at that point, but a copy of the keys. Let me do that next. I'll create another variable, copy of keys, and set that to a new tree set, passing contacts.keyset to the constructor, and I'll print it out. Here, I'm doing something similar, except I'm passing the result of calling keySet to a tree set constructor. Let's see what that gives us. My keys are now in alphabetical order, as you can see. I can use the contains key method on the map to see if the element exists by key. I'll call that in an if statement and look for the key name Linus Van Pelt. If contacts have a key matching that, I'll print that Linus and I go way back. You can see that's a lot easier than previous attempts I made where I created a contact instance with a matching name to try to find a match. What's neat though is I can use this key set view to remove elements from the map. I'll call the remove method on the keys view, passing it Daffy Duck, and print it. And print my contacts map as well. Running this code. Notice that Daffy Duck's not in the key set, which should be no surprise. What might be a surprise though, is that this removed the key and value pair in the map as well, and the Daffy Duck contact isn't printed out. Let me do the same thing with my copy of the key set. I'll copy those last three statements and paste that copy directly below them, and I'll change Keys View to Copy of Keys. I'll also change the contact I want removed to be Linus Van Pelt for this test, since I've already removed Daffy from my contacts map. Let's see what that gives us. As you can see, Linus is removed from Copy of Keys. Since this is a copy though, it had no effect on the original map, so Linus is still in that map. If your goal is to use the key set to manage and manipulate the underlying map data, make sure you don't make the simple mistake of passing your key set to a new sets constructor. Let's say that next I want to purge some old contacts like Lucy, Minnie and Maid Marian. I can use remove all on my key set with these three contacts, or alternatively, I can use the retain all method and name the contacts I want to keep. I'll go with the second approach. Again, I'll copy the three statements on lines 26 through 28 and paste them, this time on line 34. I'll remove and replace that first line and call keysView.retaiNall. I'll pass a list of strings, so list.of, then my list of 4 records that I want to keep: Linus, Charlie Brown, Robin Hood and Mickey. I'll run this now to see if that works. And I've got 4 names in my key set and 4 contacts in my map. Okay, so that's pretty convenient to be able to just perform functions on your set of keys and have those operations be propagated to the map. The set returned from the key set method is backed by the map. This means changes to the map are reflected in the set and vice versa. The set supports element removal, which removes the corresponding mapping from the map. You can use the methods remove, remove all, retain all and clear. It does not support the add or add all operations. Let's continue on with this. First, I'll execute clear on the keys view, then print my contact set again. Let's confirm this does what it looks like it should do. As you can see, I've cleared the contacts map of elements and a pair of empty brackets are printed out for my contacts map. Now I want to try to start adding contacts back using the keys view. I'll add Daffy Duck to the keys view set and I'll again print out the contacts. This code compiles, but now if I run it, I get an exception, an unsupported operation exception. As I stated on the slide, add operations can't be used on the keys view. If you think about that, it's kind of logical, because adding just a key is only part of the data needed. You don't have a way, if you do this, to say what the keyed value would be. Let me remove those 2 statements. Next, I'll add my contacts back, as I did before. I'll make a call to contactData.getData, passing it the email type. I'll chain the for-each method to that, adding each of these contacts to my set. I'll repeat that, but for phone. Then I'll print out the keys view set, not my map. Running this code now. You can see all my newly added contacts are in the keys view set. I didn't have to execute the key set method again to get the refreshed data. My view was refreshed automatically. This is a pretty powerful and easy way to manipulate elements in the map. Now let's consider the next view. I'll call values on my contacts map and assign that to a variable called values with var as the reference type. And I'll call for each on the result of that, printing out each element. The first thing I want you to see is that IntelliJ is telling me, with its hints, that I'm getting back a collection of contacts there. And running that code, I get all my contacts printed out. Once again, I'll use the retain all method, but this time using it on the values collection, passing it the emails retrieved from contactData.getData. I'll print the keys using my keys view, and after that I'll print my map's keys and values. Let's see what that gives us. Notice that the keys view and the map have the same contacts as the email contacts, even though the contacts attributes, phone in some cases, may not match those in the email list. I was able to change my mapped data by using a values view, which was then also reflected in the keys view. I'm going to add a method to the contact class that will return the contact's name listed as the last name, comma, then first name. I'll add this just under the getName method and call it getNameLastFirst. This will return the last part of the name from the last space to the end of the string, followed by a comma, then followed by the first part of the name from the beginning of the string to the first space. What's nice about getting the values back as a collection is you can pass this to any other type of class that implements a collection. That's what I want to do next. Getting back to the MapViews main class, I'll first add a separator line, I'll create a new array list and pass values to the constructor. I'll sort the list using my new method, with the helper method comparing on comparator to do that. I'll print out the elements in my list, including a call to the new method name, and then printing the contact info. Does this work? Let's try it out. You can see I have a nice printed list, alphabetical by last name. One thing I haven't demonstrated yet is adding a duplicate contact, but under a different key name. So let me do that with the first element in my list here. I'll print a separator line, then set a local variable to the first element in my list. I'll call putOnMyContacts map, but instead of using name for the key, I'm going to use my new method, getNameLastFirst, and I'll pass first as the value. Now I'll print out the values collection view using forEach. And after that, I'll print the keys in keys view, running that. As you can see, the output shows two Daffy Duck contacts, but the keys are unique because duck, Daffy is different from Daffy Duck. I can also pass my values collection to a hash set, which also takes a collection as an argument to the constructor. I'll set up another local variable called set, a hash set of type contact. I'll set that equal to a new hash set, passing it values. Then I'll print the values in this set. I'll also test if the size of this set is less than the size of my contacts maps key set. If it is, I can assume I have duplicate values in the values collection, and I'll indicate that is the case. Let's check that works. I have 5 elements printed from my set, and I see that the duplicate values message was also shown. Okay, so I've covered 2 of the 3 view collections. The final view collection is the entry set. I showed you earlier slides that key value pairs are stored in instances that implement map.entry. In the hash map, this is the node. I can get a set of these nodes and examine them. I will do this here to look for keys that aren't in sync with their contact name. I'll set a local variable using type inference and call that node set, making that equal to contacts.entrySet. I'll use an enhanced for loop to loop through what I get back. I'll just use var for the looped element and call that node. On any node or map.entry instance, there's a getKey and a getValue method, which return the key value pair of this node. I'm comparing the key with the values name field here. If they're not equal, I'll print the key doesn't match the name, and then print both the key and the value. If you have IntelliJ's hints turned on, you'll see that node set's type is a set of map.entry, the key type is string, and the value type is contact. I will run this now. And the result confirms what I already knew, that I have a key value pair where the key doesn't match up with the contact name. I'll change this code for my more curious students and add 2 statements to print out the class name, first right after the node set. Then I'll also include that for the node in the if statement. Running this now. You can see what these instances really are. Both are nested types on the HashMap class itself. If I go up to my HashMap instantiation on line 9 and control-click that class, that opens the source code for HashMap. I'll look for class entry set first, using Control-F. That will take me to the nested class declaration. This is an inner class declared as final. I'll explain why you'd want to use final as a modifier for some classes in an upcoming section. Here it is, preventing classes from extending this class, including classes that extend the HashMap. You can see this class is a set. It extends an abstract set, and its type is a map.entry. Let's look for node next, so I'll change entry set to node in the search box, and that will take me to the class. This one is a static class and implements the map.entry interface. I'm sure I've said this before, but you can learn a lot if you take a little time to explore the code in Java's class libraries. This video is getting a bit long, so I'll bring it to a close. At this point, I've covered the major functionality on the map interface using the HashMap to do it. In the next video, I'll give you a challenge, which I think you'll have some fun with, So I'll see you in that next video.